Dear students, good afternoon everyone. My name is Sheikh Rahman. I am from Civil Department, at present working in Amrong Engineering College at Kodad. So in this section we are discussing about the one of the beautiful topic about the groundwater hydrogeology related course point of second unit related. The topic name is nothing but the ducties and themes equations. This is equation. Nothing but of the entire second unit topic is represented by the or knowing about the given information about the steady flow of water into the well. Nothing but a flow of water. The steady flow groundwater flow towards the well. Nothing but of according to our syllabus point of we are discussing about the nothing but of the unconfined aquifer and confined aquifer point of the water should be flowing. Steady flow of water, groundwater should be flowing into the well. Maybe in the case of sometime confined aquifer, sometimes unconfined aquifer point of that will be flowing. So particularly that particular point of according our we are now starting about our topic point of our concept point of so ducties and thesems equations. So nothing but of the in steady state groundwater flow towards a well, ducties equation, what I am saying in starting time, ducties equation, and for used for the unconfined aquifer point of the themes equation should be used for the with help of Dashes law point of we are using for the confined aquifer point of. So my dear students, a basic information nothing but about the maybe any kind of equation, maybe ducties equation or themes equation, what it may be, the both two equations will be based on the equations will be forming because of the Dashes law. The Dashes law is the parent material for the two kind of equations point of basic equation for to get for the ducties equation or maybe themes equation. So especially maybe content point of subject point of so well hydraulics point of maybe the groundwater steady flow groundwater flowing towards well point of. Two kinds of equations are mostly useful for well hydraulic analysis point of maybe analysis of the well hydraulic point of or pumping test data point of we are using by the two kind of equations. One is ducty equation and second themes equations. So particularly at ducties equation is a brief information point of in 1863 nothing but of the ducties will be form a original derivation or equation from the steady flow groundwater flow into towards well point of. In 1863 he proposed the equation, but later the themes should be that will be will be modified based on some their drawdown values point of maybe depression head point of or maybe cone of depression point of the water levels differentiation point of radius point of. It should be slightly modified. That equations we are called by the themes equation. When we modified 1906 it should be modified. So this is a brief information about the ducties equation point of themes equations point of. We are moving original content point of those applications, how to be are useful, what kind of formulas we have to be applied. So let hear this one. So themes equation nothing but of the themes equation is derived from the Dashes law. I already told you. So I already told you nothing but of this equation should be come from the Dashes law. It is used to calculate the discharge Q from a well in a confined aquifer. So nothing but of the formula is nothing but of the Q is equal to pi kb H2 minus H1 by log R2 by R1. So my dear students, particularly here the kb also write sometimes nothing but of the T. If in case maybe nothing but of the hydraulic conductivity K into B, thickness of the aquifer also called into T. So sometimes the discharge of the confined aquifer point of the equation Q is equal to discharge Q is equal to pi T H2 minus H1 by log R2 by R1. In this case of when we are applying this kind of equation, because of the having two observations well will be there, in the problem or in the case study point of these kind of formula we have to be applied. Then Q is equal to 2 pi kb or H2 minus H1 by log base C or maybe log 10 R2 by R1. So R1, R2 are represented by the nothing but of the radius, nothing but of the radial distances with respect to the two observations well point of. At the same time, K is hydraulic conductivity of the aquifer, B is thickness of the aquifer. H1, H2 are the hydraulic head. Already I told you head loss point of maybe I think the drawdown point of depression point of we have to be modified. I already told you. So that based on that the equations will be modified. This equation modified the themes. Okay. So here in case of maximum required by the radial distance capital, if you are required, the formula is nothing but by the 2.72 bk capital H minus small h by log 10 r by r. Otherwise it will be modified nothing but by the bk is already we are trying right about the t, and capital H minus by small h nothing but of the total aquifer thickness height is h, small h is the initial water level stage, so head of the water level at present that aquifer. So maybe that will be divided nothing but driven by the capital H minus small h is equal nothing but the s drawdown value. So that particular point of we want to be calculated by the any discharge of the well, the movement of the well, a point of groundwater flow in that well point of Q is equal to 2.72 bk s by log E capital R by R. In case of maximum two hydraulic wells, two wells will be applicable point up, then we are writing about the Q 2 pi t H2 minus H1 by log E R2 by R1. Okay. So based on that case study, based on the requirement point of these has to be changes. Okay, Nana? So next one. So assumptions, the particular assumptions point of the aquifer is homogeneous, yes, nothing but of the homogeneous isotropic, and if the infinite aerial extent, nothing but homogeneous means same type of parameters and qualities will be maintained. Isotropic point also maybe the value should not be changed entire of the aquifer based on that aquifer point of the properties drawdown value, nothing but the properties of the aquifer, nothing but of the gradient, hydraulic gradient I, at the same time of radial distance, nothing but small r radius, at the same time of particularly that values of the head loss, nothing but of the hydraulic gradient I. So based on that, those are the same, but maybe as a confined aquifer, unconfined aquifer point of those have the same parameters. Maybe assumptions point of, maybe Dukes point of, thesis point of, those aquifers are the homogeneous and isotropic and of the infinite aerial extent. The flow is steady, yes, the flow is steady, laminar, Darcy's law is applicable. Maybe that with base, already I told you the base material, parent material is nothing but Darcy's law by the two equations point of. In this case of also, without Darcy's law, we can't do these kind of practical observations, these kind of equations, these kind of problem solution will be based on Darcy's law. So the flow is steady, laminar flow, Darcy's law is applicable. Nothing but Darcy's law, Redan number less than 1 will be there, then only we have to be applicable, then only that kind of flow we are called laminar flow. So next one, the well fully penetrates the aquifer. Yes, the well should be fully penetrate of the well, then only the water will be flowing upward direction, will be discharged easy for us. So at the same time of the piezometric surface is horizontal before pumping begin. So my dear student, given some clarity point of what is piezometric surface, nothing but of the, so nothing but instill static water level also, and the piezometric surface also we are same representation. So nothing but of the, where it may be before pumping of the well, the water level having some much of height. After pumping of the water in that well, maximum the water level should be drawn down, must and should fall down. That we are called nothing but of the particular, and that we are called drawdown values, and also fall down values, nothing but that we are called cone of depression. So based on the cone of depression, maybe the following following of the water levels. That we are represented by the with help of the nothing but a drawdown values point of. So actual water level minus after pumping water level is represented by the drawdown S values. So in this case of also the piezometric surface is horizontal before pumping begin. So based on that, the requirement of discharge, based on discharge, that piezometric surface levels also be changed. But at the starting of the aquifer pumping, that piezometric surface is horizontal before the pumping begins. So dupe these equations. So dupe this equation. This equation is used to calculate the discharge Q from a well in unconfined aquifers. Yes, my dear students, unconfined aquifer point of we have to be calculated flow rate or discharging point of. We are using by the dupe this equation. Q is equal pi k h2 square minus h1 square by log E R2 by R1, where K is hydraulic conductivity of the aquifer and H1 H2 are the saturated thickness water table elevations, the radial distance R1 R2 from the well respectively. Yes, my dear students, here particularly that dupe this equations point of these also the homogeneous and isotropic formation, but Q is equal pi k H2 minus H1 by log base E R2 by R1, that actual formation equation for. But particularly when will be applying, because of the two wells identification point of maybe those are having water level variation point of we have to be applicable. But when we are having required by the length and capital R point of, particularly given by the length and capital R point of, so the equation is equal Q is equal pi k S nothing but by S pi k S L by S by 2 log E capital R by R, nothing but what I am saying equation 2 pi k S L plus S by 2 by log E capital R by R point of small r point of. L is nothing but of the length, the particular aquifer length we represented. S is nothing but a drawdown values. Capital R is radial distance. At the same time of K is hydraulic conductivity. So based on that values we should be identified by the what kind of discharge having a dupe this equation at particularly unconfined aquifers point of. So maybe in case of having by the any two types of water levels will be there, H1 H2 values will be the two pumping test wells point of that what we are mentioning in the slide point of this equation is the suitable. Q is equal pi k H2 square minus H1 square by R2 by R1 log R2 by R1 point of. Okay, so next one, exemptions point of the aquifer is homogeneous isotropic. What I am saying that we are satisfied here. The aquifer is homogeneous isotropic and of infinite areal extent. The flow is steady laminar and Darcy's law is applicable. The well fully penetrates the aquifer. The hydraulic gradient is small and the flow is horizontal and uniform across the vertical section. Dupe this assumption is that the velocity of the flow is proportional to the tangent of the hydraulic gradient rather than the sign. So nothing but of the aquifer is already I am told you homogeneous isotropic, yes, infinite extent. The flow steady laminar, Darcy's law is applicable. Both or equations comes from the Darcy's law point of, so Darcy's law also be applicable here. The fully penetrated may be unconfined point of, confined point of, the well should be fully penetrated into the aquifer. So the hydraulic gradient I is nothing but of the delta H by L. The hydraulic gradient should be very small, then only it will be applicable. Otherwise it not able to applicable for the dupe equation here. So the following horizontal uniform across vertical section. The horizontal uniform, nothing but the hydraulic gradient is very high, that informed by the vertical formation. If the hydraulic gradient is very small, less, nothing not having very small, that will be horizontal formation, uniform area at vertical section point of. Based on that the section of the slope will be dependent. So nothing but of the velocity of flow is proportional to the tangent of the hydraulic gradient. Yes, if in case the slope will be more, the velocity will be more. The slope is nothing but a gradient, hydraulic gradient is less, so nothing but of the flow of water also very slow. So nothing but of the natural general phenomenon, the water will will be flowing upward as to the lower downward direction, low direction point of view only. Okay, so next one. So now ready for the conclusion this topic, this section. My dear students, recall about the small brief information recalling about the topic. So today we are discussing about the one of the beautiful topic, basic content of the basic concept of the two small topics, concept of the second unit point of that particularly having the unit is nothing but of the our second unit point of unit name is analysis of pumping test data 1. So in this case of maximum we are studying about the steady flow groundwater flow towards a well. So in this case of we are studying about two kinds of equations. One is the Duptis equation, second one is the Thames equation. So Duptis equation, Thames equation point of the Duptis equation is used for the unconfined aquifer point of, the Thames equation is used for the confined aquifer point of. So confined aquifer point of having by the formula is equal nothing but of the having two hydraulic testing wells will be there. Q is equal to pi kb H2 minus H1 by log R2 by R1, the formula. So nothing but K is hydraulic conductivity, nothing but of the K is equal, B is the thickness of the aquifer, and H1 H2 are the two hydraulic heads with reference of the testing well point of. R1 R2 are the radial distances from the respectively from the well radial distances. Okay, so if in case if you want to be if you want to be any capital R point of, so the Q is equal to pi k b s by log R by R. So sometimes we written this equation is Q is equal to 2 pi K into B, generally hydraulic conductivity into thickness of the B is nothing but of the transmissivity. So we simply write down this equation, Q is equal to pi T H2 minus H1 by log E R2 by R1. Otherwise Q is equal to 2 pi K, 2 pi 2 pi 2.72 2 pi K or 2.72 T dot S, nothing but of the cone of drawdown value by the log E R by R. Okay, based on that problem, based on that case, we should be modify the equation, change the equation based on our requirements point of. So assumptions point of this will be nothing but of the maybe these are maybe things equation both are satisfied two or 3 points. Both are aquifer or homogeneous isotropic formations. Both are well penetrate into the aquifer. Though both are satisfied by the Darcy's-Law equation. Darcy's-Law, both are laminar flow only. Based on that, these themes point of the water pumping levels will be changed based on that pumping starting time 1, pumping before starting 1, pumping starting then. After some time, it will be one kind of water levels will maintain. Okay, so next one we are studying about knowing about the Duptis equations point of that will be useful for the only only useful for the unconfined aquifers point of that equation having the Q is equal pi k H2 square minus H1 square by log R2 by R1. If in case having by the any capital R, if you want to requireable based on that length point of having by the having by the 2.72 Ks by L plus S by 2 log R by R small r. Okay, so in this equation also when nothing case hydraulic conductivity, I think value is length of the aquifer, capital R is radial distance, R is the radial distances by the R1 R2 from the well. So S is nothing but of the drawdown values. Okay, now so assumptions point of same, both what we are studying about those assumptions are same, but based on the hydraulic gradient point of the water flow velocity will be changed. There the water levels will be pumping, before pumping one type of level maintained, after pumping one type of level maintained, but here the water flow will be based on that hydraulic gradient. If I is hydraulic gradient, I is normal very low, the water flowing velocity very slow. Having I is more, automatically here the flow of velocity will be more. So my dear students, this is the time for the conclusion of this section. If having any doubt, please text me as possible as I will reply. I will gain better knowledge according my knowledge point, better knowledge, better information, and betterly clarified your doubts based on your requirement point of. So thank you, my dear students. Today I am concluding this section. Thank you very much.